You are a bacterium. Your face is a bacterium. Okay, so here's what we got. We are going to go over the Unit 10 review. Where's your review? Okay, so where is it? So shouldn't you, instead of playing on electronics, Ethan Lee, I'm going to ask your mom to watch the video, have requested a blank copy, so perhaps you could stay up and work on it. Would that have been a better decision than playing on the electronics? Okay. So come with me. Come with the electronics before I throw it in the pond. Okay. As I was saying before I was distracted by Ethan's addiction to electronics, so we're going to go over this review, rather than just saying, does anyone have any questions? I'm going to go ahead and work most of them fairly quickly because I need you to see the smart ways to do these. If you still have questions, then ask a question. But sincerely, some of y'all are still a little bit fuzzy on how to, the smartest way to get to an answer on some of these things. Some are going to be more calculator driven, some are not. So number one, it says graph y equals 3 times 2 to the x. Before you do anything, is this exponential growth or decay? How do you know it's growth, Avery?
Because the one in the parentheses is bigger than 0.
Because the base is greater than 0. So right off the bat, this one's out. Right off the bat, it's out. Okay? Because that's obviously exponential decay. So what should we do now to find the right answer?
Oh, you should plug it in your calculator.
Yeah, plug it in your plug in your calculator. And then go to the x power, and then hit the graph button. And then find the graph that matches it. Now, according to the calculator, it has an asymptote. In other words, what line is it approaching infinitely, according to the calculator? It's approaching 0. So this one's out. These two are the only ones left. And now the smartest thing to do is to go off the y-intercept, right? So what is the y-intercept? The y-intercept is indeed 3, and if you're not sure, you can look at the table. And the y-intercept is where x is 0. This has a y-intercept of 3. This does not, meaning D is your correct answer. Got it? Any questions on that? Okay. Number 2, suppose 2 mice live in a barn. The number of mice triples every 3 months. How many mice will be in the barn after 2 years? So this is an exponential growth. And remember, exponential growth is y equals a times 1 plus or minus the rate to the time interval exponent, or the x exponent. So in this case, we start with 2 mice. It is definitely going to be growth, because, you know, they're tripling. What's the rate on triple?
2.
2. The rate is 2. And then you have to think of this. It's happening every 3 months. How many 3 months are there in 2 years, Joey?
8.
There are 8. And then once you get that, it's simply a calculator function of 2 parentheses to the 8. And you get that those 2 little mice end up creating a family of 13,122.
Oh, that's a big thing.
That's a very large family. That's a very long, tiny little table for Christmas. Right. So, first of all, gross, and I'm saying. So anyway, the function f of x equals 5,000 times 0.972 to the x power, where x is the time in years, models a declining lemon population. How many lemmings will there be in 6 years? At this point, all you have to do is what? Plug it in. So we end up with 5,000, parentheses, 0.972, caret 6, 4,216.65, or 4217 about. Good to go? And finally, which function best models this data? How did you solve this one? Mark, what did you do? That is exactly how I would have done it. What did you do, Kiana?
I went to y equals and put all those in and looked for the
Ooh, that's even better. Okay, so everyone hear those 2 options? Okay, so Carden simply plugged in the x's and the y's into the equation to determine which one worked. Kayana plugged in all four into y equals. y1, y2, y3, y4. Checked the table and found the one that matches for all those particular x values. What'd you get, Kayana? C. Okay? You have a question, Ethan? Okay, that's a really good question. Ethan said, could you have used diagnostics? I would not, and I'll tell you why. Because how do you know? Well, it's not an estimation. Guys, here's the thing, diagnostics, that whole stat edit process is really used to determine the line of best fit. Or the function of best fit. Is the function of best fit linear or quadratic or exponential? It's really not meant to just find you an equation. It's really not built to find you an equation. If you get an x and a y function, just plug in the x's and y's until you find one that works. Okay? Does that make sense? Any questions on the first page? Yes?
You said you wouldn't do the diagnosis.
I would not. I know. But I'm saying, if you have x and y, I would just do that. Okay? Any questions on that? And by the way, stat edit takes longer than just throwing in the functions and checking them. Gentlemen, what are y'all doing? Oh, it's science day. Are y'all sciencing? All right, good luck. It's science scavenger hunt for 8th grade. Every year, right before the science star test, they do a big, huge campus-wide science scavenger hunt to get ready for the science star test. Okay. Number 5. In the year 2000, the population of Mexico was about 100 million, and it was growing by 1.53% per year. 1.53% per year. If this growth rate, the function, gives the population in millions next year. Using this model, what year will the population reach 111 million? Guys, what does 111 million represent? It represents your output or your y, which means, in this case, they already give you the function. You simply go to y equals, you type in that function, 100 parentheses, 1.0153, close parentheses, caret x. You go to the table, and you look for when the population reaches 111 million. Now, let's talk about something real quickly. So, say we have this. We have 5, 6, 7, and 8, right? 5, 6, 7, and 8. And 5 is 107.89, 109.54, 111.21, and 112.92. It reaches 111 million sometime right there, right? Do we know whether it happened in year 6 or year 7 based off what you see? You actually do. You know it happened during year 6, and I'll tell you why. Because the minute it turns year 7, that's what happened. So really, it happened at the end of the 6th year. Now, in this case, you know that 2006 is not an answer choice. So 2007 is the smartest answer choice because they're rounding. But do you see how that works? That's why you have to be very careful about interpreting the information. Okay? Number 6, a radioactive isotope has a half-life. Did we talk about the half-life? Yes. So we know it's decay. So we know it's starting point times 1 minus the rate to the x power. So starting point is the 400 milligram sample. It's 1 minus half because it's a half-life. And then we have to be careful on time. Remember, it's how many 13 hours this is there are in 52 hours. In this case, it's 4. Okay? Any questions on that? So once you punch this in, what do we get, Pete?
Oh, you did 45.
Okay. Oh, do not think. No thinking.
No, I know. What? Why? I like it. Actually, I would like it.
Yeah. Okay. A computer, stop it, be nice. A computer valued at 6,500 depreciates at the rate of 4 points, depreciates, decay. So we end up with 6,500 times 1 minus 0.143. Is anyone still not sure how to convert a decimal to a percent to a decimal? Okay. Or just divide by 100 your calculator and hit enter. Either one works. Okay. So to the 3, and you punch it in. Here, I'm going to mark it. Well, this is not your key, it's my key. Hold. Wait for it. 8 times 2. So we have $4,091.25. Questions? All right, so John's got a pay gig. He makes $7.50 an hour. He's going to get a 2% raise. By the way, that's horrible. Every 3 months. What was that thing in 2 years? So again, the only real trick thing is the time thing, right? So we end up, it starts at $7.50. It's a pay raise, not very much of one, but it's a pay raise of 2%. And there are 2, 3, 4, 5, 6, 7, 8 3 months in 2 years, which gives him a pay rate of $8.79 after 2 years. Dude, I feel bad for John. Y'all can't even take out his lady, because he's making $8 an hour. Stay in school, folks. Stay in school. My son got a job over the summer, like $16 an hour. I am so excited. He's teaching computer programming for a youth camp in Frisco. And they get all his interviews over the phone. He did 3 interviews, not over the phone, over the face thing. And yeah. So, and his last one was where they were interviewing him, and they said, okay, so we want you to write an original program, and they gave him some parameters, and then they gave him 60 minutes to write it. And they call us back in 60 minutes. And so they gave him 1 hour to write a program. It was a game, and he basically wrote a Pac-Man game in 1 hour, coded it. So they gave him a job. I felt happy. 16, $60 an hour. I'm retired. Okay, so in 1980, the population of Boyd, Michigan was 161,000. Since then, the population has decreased 1% per year. For current trend continues, predict the population in 2015. So really, the only thing we have to pay attention to is what in this? The number of years, right? So we end up with 161,000. By the way, really quickly, because I saw a kid do this the other day. When you have like 13 million as a starting point, don't use 13, 000, 000. Just use 13 and make your answer million. Okay? Like there was something the other day where I saw some kid doing. He was like, "How many zeros are there in a billion?" I was like, "Why?" And yeah, it was one of these questions. Which one was it? Yeah, we'll get there. But anyway, he was doing 0, 0, 0, 0, 0, 0, 0, 0. So I told him there were 24 zeros in a billion. Just kidding. That was funny. If he wrote that all the way across his page. Oh, I know. Well, first of all, don't ask me how many zeros are in a billion when you have a freaking phone. Because you know, you can look it up. Okay? Okay.
You should know how many zeros.
80, 20, 35. Right? To the 35th power, which gives you 113,255. Any questions on that? All right, almost done. Stay with me. Which of these show growth and which of these show decay? What is the only thing that matters? So, yeah, the thing that has the exponent, the base of the exponent is all that matters. So, growth, decay, and growth. By the way, pay attention on like a standardized test. If they were to say it's 5/3 to the x power, that is growth. Very good. Growth is greater than 1. 11. A new $26,000 car depreciates by 8% every year, and that's not true. It depreciates way more than that. 1, 2, 3 times 1 minus 0.08 to the x, y equals. In the 6th year, when we plug it in, it's going to be worth 15,765.23. This is essentially, guys, stay with me. It's essentially where x equals 6. Now, When does it become less than 100?
And this is
Now, that's another thing where you have to punch it into your y equals. You go to the table and you see at which year it becomes that less than $100. And that is in the 6th year. That is in the 6th year. Any questions on that? Because sincerely, I would. Oh, I'm sorry, 66, my bad. 66 year. Sorry about that. Any questions on that? Because some of you had a different year, but it's because how you were interpreting the y. And do not plug this in. I mean, you're literally looking at the y values on the table. That's the best way to do it. Okay, geometric sequencing. How do we find the common ratio? How do we find it, Madison?
If you have like two numbers, you subtract the first one from the second.
That's not true. That's an arithmetic sequence. You divide it. You divide the second number divided by the first number. In this case, if you were divided 6,000 divided by 12,000, you would get a rate of 1/2. Divide, divide, divide. So then you just keep going, which gives you 750, 375, and 187.5. And the nth term is found by taking the first term, 12,000, times the common ratio to the n minus 1 power. If I said, what is the 100th term? If I said for this, what is the 100th term in your calculator, it will be 12,000 times 1/2, caret 99. Because that's 100 minus 1. That's how you use the formula. Number 13. Number 13, the R value is -3. The next three are 750, 300, wait.
wrong one.
Yeah, I'm reading it wrong. Joey, I blame you.
Why?
I don't know. -243, 729, and -2,187. In term, first term, times the common ratio to the n minus 1 power. Questions? All right, almost done, Pete. Last page. Population of wild Mustangs. What do we know when it doubles? Rate is 1. We know that the rate is 1 when it doubles, and it happens every 4 years. Be careful where it's saying it's happening every whatever that is. 20 years, so we know it's growth, so we have y equals, blah, blah, blah. There are now 50. It doubles 1 plus 1 to the 5th power. And we get 1,600 Mustangs. I would think there would be. There's some like this cowboy territory in Nevada, especially in the northern and eastern. The world population in 2000 was 6.08 billion. This is where they were doing this thing. And if you want to do zeros, there are 24 zeros in a billion. The annual rate of increase is about 1.26, with the population being 2040. So we end up with 6.08, unless you want to do the zeros, times 1 plus 0.10126 to the 40th power. Ooh, that's a lot. 10.03 billion.
I did 10.3.
Almost done. Now, function notation, really quickly. Remember, guys, and this is for future as well. I still want you to do this one, and then subtract it, right? So in this case, we end up with -2 minus 16, which is -18. In this case, we end up with -0.125 plus 0.25. And if you're not careful and you don't use a calculator, you might get a wrong answer. But if you use a calculator, you'll get that it's positive 0.125. Did you really? Did you get it wrong?
I forgot with negative.
crazy. Okay. In this case, you're up with 4 over negative 8, which is negative 1/2. Please box your wait. Oh, wrong.
I figured it out.
You end up with 4 over negative 1/8. Is that right?
Yes.
4 over negative 1/8, which is negative 32. And then you want to box the answer, otherwise it breaks turn out. Okay? And lastly, you end up with negative 8 minus 16, which is negative 24. By the way, when you're doing this on a test, just don't make a silly mistake and give me something because you didn't subtract right. You have a calculator, and you have fingers and toes. Okay? You what? Yeah, you can use those fingers. I'm used to that. Just make sure, you're not wearing like old socks or wet shoes, because I'm just saying. Wet socks. Or worse, when the kids who like don't wear socks with tennis shoes.
That was one time. No, one time she did it.
Yeah, you'll do it once, you'll never do it again, right? Or girls, no offense, but girls, Chads.
Those are bad.
Chads are
Some girls
bad.
don't wear socks.
We have a place in our garage for Chads because they are not allowed in the house. I told my daughter, I was like, no.
My
Yeah.
friend is like, it feels weird to wear socks. I'm like,
Cheerleaders don't wear socks.
Find a new friend. What, Spencer? 3248. Tissue box? For whom? Oh, is it Fraser Rosa Crawford? Go over there on the bottom. Keep going. Grab one of those 3-packs. Take them up there. Tell her happy snotting from Mr. Smith. May the snot be with you. Are you? Okay. Any questions on the review? Hey, listen to me. No kidding. This is a good test. It's a great closed summative grade. But don't be silly. It's going to be very similar. Very similar. Yeah. He has a drinking problem. All right, guys. See you tomorrow.